Welcome to Old School Chemistry. Today we're going to do the ALEKS topic, understanding how electrostatic force scales with charge and separation. Really, this is Coulombs Law, and I love Coulombs Law. Coulombs Law, let's unpack this. Love it. So we have potential energy, that's your VE. And remember, potential energy is an energy of position, okay? An energy of position, like two objects being here, two objects being here, an energy of position. And it is Q1 times Q2 divided by d squared. Q1 times Q2 represent two charges. Those could be a positive and a negative, which means they attract. It could be a positive and a positive, which means they repel. Okay, so two charges. And then d squared is the distance between those charges. Now check this out. The outflow of this, totally mathematical. The greater the charge, the greater the energy. If you have a bigger number here in the numerator, you're going to have a bigger quotient. So if I have charge 2 and 2, that's greater, that would be 2 times 2 is 4, that would be greater than if I have a charge 1 and 1. That would be 1 times 1 is 1, your potential energy would be 1. If you have 2 times 2, that's 4, your potential energy would be 4. Huge impact. Now the distance, check this out, is in the denominator. So think about this. The smaller the number in the denominator, the larger the quotient, which means the distance between the two charges, the closer they are, the greater the potential energy. Now you and I, this is super intuitive, very intuitive. Come back to the Q1, Q2. If you have two stronger magnets, yes, they will attract with greater force. Easy. Same thing here. The closer you hold those magnets, the greater the attraction. The further apart those magnets, the weaker the attraction. There's the principle. So let's look at this. In this particular problem, they're doing attraction because we have opposite charges, a positive and a negative. So always we're going to compare numbers first, the charge number, and then the separation. If there's a tie, if there's the same distance separation, you always go to the number to break that tie. I tell students you always look at charge and then we go to distance. So I have a +1, -1, and notice there 1, 2, 3. 3 grids apart, 3 lines apart. Here, oh, a -3 and a +1. 1, 2, 3. So same distance apart, but a greater number, a greater charge, that would trump. So right away, I know that this is going to be stronger attraction than this one. Even though they're the same distance, which makes sense. They're the same distance, but this positive is 3 times the charge, so greater attraction. Let's keep looking. This is 1, 2, 3 apart, all -1 +2. Okay, so between these two, which one's going to be greater? The 3, that -3, because this is only a +2. And don't worry about the positive negative. You're just looking at the net charge between them. And then here, oh, look at this, 1, 2. So this is going to be 2 spaces in between. This is 3 spaces in between. So this has the greater charge and it's closer, okay? A greater charge and it's closer. So ranking this, we're going to have the strongest attraction right here because it's only 2 spaces apart, -3. Then we're going to have this, it's going to be the second strongest because it's -3 and the 1, 3 spaces apart. This is 3 spaces apart, the 1 and the 2, so a little bit less. That'll be a 3, and then this one, 3 spaces apart, and it's just a 1 and a 1. All right, let's check it. Hooray, hooray. Let's do more practice. Okay, I'm so glad we got this one. Okay, so now we're looking at repelling. Well, still the same principle, but rather than the force of attraction is the force of repulsion. We use the same principles. We're going to look at the charge, and then we're going to look at distance. So I have a -1, -1, repelling each other, and they're 1, 2, 3 apart. Here, 1, 2, 3 apart, -1, -2. So between those two, which one has a greater repelling force? This one, because of the 2. That -2 is going to have a greater ability to repel from that -1. Here, 1, 2, 3, 4. Okay, 4 apart, 1 and 1. So far, that's the weakest. And then here, look at this. Only 1, 2 apart, and you've got the -1, -2. So let's rank these. This will have the greatest repelling force because it's the closest with the highest numbers. Okay, let me say that again, closest with the highest numbers. This is going to be the second strongest repelling force because it's the highest numbers, but a little bit further apart. And then here we have the smallest numbers in charge, but they're closer than this one. These are the smallest numbers and even further apart. Let's go ahead and check that. Okay, nice. So remember, you can look from the perspective of the attractive force or the repelling force. It's the same principle that we are thinking, what's the charge? Okay, that numerator, hugely significant. And then you compare the distance, how close they are. The closer they are, the greater that force. Well done. I hope you enjoyed that as much as I did. Please like and subscribe if you haven't already. Have a wonderful day. Thank you. Bye.